Okay. Recording is started or no? Yeah. Okay. So is this okay? So again, let me go here and tell you how does potential energy uh, diagram can be plotted for a reaction. We know for a molecule, am I right? This AB, when A and B is coming together, what will happen? When A, B dissociated quite far apart, then potential energy will be zero. When it comes closure such that attractive forces are predominant, then potential energy will decrease. And when repulsive forces is predominant, then it will start increasing. So that is how potential energy for two atom system looks like. But if I take potential energy of three atom system, variable will be three, and those variables will be R1, which is distance between 1 and 2, R2, which is distance between 2 and 3, and then angle between these two. Okay. So there will be three variable, and that will be given by this equation 3n minus 6, which is the number of vibrational degree of freedom. If I take this theta fixed and now I give it a value of 180 degree, and it means that all three are in a straight line. In that case, since I fixed one of the value, and so number of variables now is 2. And now it is easy. Why I am doing that? Because I want to have a plot in 3 dimensions. So there will be 3 dimensions. In one dimension, you plot potential energy. In another dimension, you can take R1 and then R2. Now, if I plot, it is not very difficult to understand. If I plot it, so let's take potential energy on the Z axis. So this is potential energy on Z axis. Okay. And then potential, this is the HBSC distance. This x-axis, if you take, this is HBSC distance, and this is HAHB distance. Okay, HAHB distance. So now take this reaction HAHB to SC. Okay, and suppose the SC is quite far apart. It means you are looking at the potential energy of HAHB. Okay, so HBSC is quite far apart. Am I right? Here HBSC. So you can look at, if you go at, so this is HAHB distance and this is HBSC distance. So HBSC distance is high, means this point you are looking at. All right, this is your HAHB distance. Sorry. This is HAHB distance, and that plot you can see here. All right. So this is for reactant. Okay. Here, so when HBSC distance is, what does that mean? HBSC distance is 0. Okay. HBSC distance is 0. At this point, HBSC distance is 0. HAHB distance is quite far. So you are looking at product. Am I right? HBSC distance is 0, and then HA distance is quite far. So this is your product, and it is quite similar. Am I right? So you are looking at basically potential energy of HBSC. So potential energy of HBSC will go like this. And now see this side. At this point, your HAHB is 0. Am I right? So you are looking at, and SC is quite far. So HAHB distance is 0. So for HAHB, it will look like this. Am I right? What you are changing is HAHB distance. Sorry, just 1 minute. Let me. So here you are changing HBSC distance. Okay, and HBSC distance, and then HA-HB distance is quite far. Okay, so HA-HB distance is quite far means you are looking at product. And similarly here, HBSC distance is quite far, so you are looking at reactant. So you have this kind of curve. So this is your for reactant and this is for product. And so basically if you want to go, so this curve is basically like this, you know, that you have value, this is like high energy thing, and this is your high energy. So if you take any other position, this will be, this is, you can think of lowest point in here where this corresponds to distance between HBSC, right? HBSC. So this is the equilibrium distance and this is equilibrium distance of HAHB. Okay, so you are going from this to this. You have to come from this point to this point, right? And if you look from two sides, you see this side is heel, this side is heel. So it is like two side heel, and you are going from one valley to another valley. Okay, from this side, it is the highest point. And from, you know, if you take horizontal, this axis, then this is lowest point. And these points are called saddle point. Okay, this point is called saddle point. And what this plot which I showed you, am I right? This is basically here. You are going from this. So what you are trying, if suppose it is like, uh, if you go, it is something like, it is analogous to when some, person who is doing skiing is trying to go from one valley to another valley. Okay. So what he will try to do is he will like to go through a pass in which this is your lowest point, lowest height. Okay, pass. So it will go between two hills. Although this is lowest point in horizontal direction, but it is highest point in this direction. And basically this thing what you are seeing is going from this side to this side. Okay. Is it clear? Any question here?
So how is that the highest point?
Okay, you see here, this is the lowest point.
Yes, sir.
यहाँ पे lowest point है, but अगर बीच में if you take any point, it will be higher than these two.
Yes, sir.
So you are going from this point to this point, and there will be a hill. But you look at, you are going from this side to this side. So in this direction, it is the, you know, it is in this direction. If you look at, this is the lowest in energy. And that kind of thing is known as saddle point. I'll show you from some pictures, but is it clear what I'm trying to say? So basically, this is the point here, reactant HA, HB, SC is quite far apart. And you can see that HB, SC distance is quite high for all these things. It means that you are talking about this reaction, HA, HB to plus SC. And then this is potential energy of HA, HB. Okay. Now see, in this case, your HA-HB distance is very high. It means that you are dealing with this reaction, HB-SC. So this is just potential energy or HB-SC. In between, so these are two extreme points. In between, it has to go from one stage, from reactant to product. And so it will go like this. It will try to take a path where it has to do minimum effort. Okay, minimum effort. So it is like you are going between two hills. You are trying to take a path. You will not try to go by this way. Am I right? This side is valley. Still, you will not try to take, because this will take this will be really difficult. Am I right? So generally, people who are trying to go from one value to another try to take this path. And same is true with a reaction. It wants to go from one value. Value means a position of low potential energy to another value. This is the value. Okay, these two are value, and it is trying to go from one value to another, and it will try to take a minimum energy pathway. That's what is called minimum energy pathway from this side. Okay, it will not try to go, you know, this way or this way. It will try to take minimum energy pathway. In minimum energy pathway, this is the maximum energy point, and that is called saddle point, or this is also known as transition state. So it is basically you are trying to go from this to this, right? If this side is reactant, this side is products, so this will be transition state. But remember, we are showing in one dimension, and in one dimension we are sorry, in two dimensions. So we are showing this pathway only, right? So this direction we are showing it, not this direction. Okay, in this direction it is the minima. In this direction, this point is maxima, and those points are called saddle point. The transition state is kind of saddle point, and the potential energy which we show generally is from this valley to this valley through minimum energy pathway. This is called minimum energy pathway. In minimum energy pathway, this point is of maximum energy. Is this clear? Okay, so let me show you with the diagram. Can you see this?
Yes,
Yes,
sir.
screen is visible.
Okay. So look, how does potential energy looks like? And if you see this, this goes like, and that is what you see. This is drawn using computer. You can calculate potential energy for each coordinate. Okay, R1, R2, just you change it, and then you can calculate potential energy, and that's what it is shown here. And you can see from one state to second state, it has to take this path. Okay. Now same thing shown in, yes, tell me.
So why is it inverted with respect to the diagram which was handmade, the previous one? I mean,
This one?
uh,
It depends how you plot. It has nothing to do with, but you can think of that this side is your RBC and this side is, this is RBC and this is RAB. And then there is potential energy. Okay. The way it has plotted 1 hour and second hour. Right. But thing is like RBC here, if you are taking it, then RAB is here 0. You see, this is RAB is 0. So what does that mean? What is maximum here? So you look at
infinity.
this side. What is the maximum is RBC? Am I right? This this plane, if you look at this surface, you look at RBC is high. It means you are looking at AB plus C. Am I right? Here, what is the maximum?
BC, RBC.
RAB is minimum.
Yeah, RBC. Just this plot here RBC in this at this surface RBC is maximum, right? So this should be, I think this number is wrong probably. That's why it looks.
I think, sir, this 0 is for potential energy.
Zero is for another reading, like for
0 is for the potential, yeah, in the vertical axis.
Yeah, it is just to plot is somewhat, this thing, but idea is simple. The way I showed you, it looks like this only. So it goes from this side to this side. So you can think one side is product, one side is reactant, and you go from this to this side. Okay. Now, if you look from upper view, it is same, because this side and here is your. So you see in this direction it is minima, and in this direction it is maxima. Am I right? Same thing here. This side is, you see, H1 S2 plus S3. This side is H1 plus S2 S3, and you have to take this pathway. And both sides, in this direction it is minima, and in this direction it is maxima, and this is called saddle point at the eddy transition state.
Sir, this minimum and maximum, please repeat it once. Which direction?
Okay. This direction, you look at this direction. देख रहे हो मेरा? Can you see highlighter?
Yes, sir.
Okay. In this direction, this point will be maxima or minima. फिर से देखो यहाँ. I am talking about this direction. Is this minima or maxima? This point.
Minima.
Minima होगा. और यहाँ से देखो. ये क्या होगा point?
Maxima.
Maxima होगा ना? ये देखो ये point. यही point है. This is maxima in this direction, and in this direction, this is minima. This pathway is minimum energy pathway. So minimum energy pathway में तुम्हारा this point will be maxima. That is called transition state. So in this direction it is minima, in this direction it is maxima, and this is called saddle point. Okay, and this saddle point represents transition state. Is it clear?
Yes, sir. Thank you, sir.
Okay. Now let us see here. Maybe. Now you see this. दिख रहा है कैसे जा रहा है रिएक्शन?
Yes, sir.
ये देखो ये पॉइंट है, सपोज इधर रिएक्टेंट है, दिस साइड प्रोडक्ट, सो इट हैज टू गो थ्रू दिस, एंड दिस साइड अगर ऐसे देखोगे इसको, तो यहाँ पे ये मिनिमा हो गया, दिस इज ट्रांजिशन स्टेट, एंड दिस साइड विच इज द रिएक्शन पाथवे बेसिकली, दिस इज मैक्सिमा. इज दिस ओके?
Yes, sir.
Sir, what was the red highlighted region? Could you repeat that part?
Let me just just 1 minute. Can you now see it?
It's visible.
ठीक है, दिख रहा है?
जी सर
Yes,
जी
sir.
Yeah, okay. Let me show you again, same diagram. So this is like, cliff. You can think of, this is BC distance. So I am talking about when BC distance is high. It means AB का हम देख रहे हैं. Just AB का देख रहे हैं. Am I right? So this is potential energy. That's how we expect. Am I right? Similarly, this side is AB distance is high. So then we are only looking at BC. And then this will go like this. Right, this is potential energy, BC distance, AB distance. These are two valleys. Okay, so valley, one valley to another valley you are going, either from this side or this side, doesn't matter. Okay, then it has to take a minimum energy pathway. Minimum energy pathway is what is known as course of reaction. And in analogy to going from one valley to another valley, you are going through a pass. And this point is the maximum energy point in minimum energy pathway. And that is known as saddle point or transition state. Saddle point or transition state. Is this clear? आया समझ में?
यस सर
Yes, sir.
Okay. Now there is another diagram which is generally shown in 2D. That is your what is known as contour map. So you are basically seeing a slide from one three-dimensional picture, and that is always used when we are trying to show three-dimensional picture to two-dimensional picture. So this is kind of potential energy that you have already known. And if you remember that, if you have some knowledge of quantum, am I right? We have been given some idea about vibrational states.
Sir, what?
बताया? Hello.
So vibrational state as in?
In this harmonic oscillator.
So harmonic oscillator नहीं कराया like.
नहीं पढ़ा गया. Okay. Anyway, this is the potential energy. You know that, am I right? यही था ना potential energy
Yes.
diagram. Okay. It is like this, and so you can see this. So these are like different vibrational states. Okay, different vibrational states, and this contour lines which you are seeing it here. This is of same energy. And you are going from this side to this side. This side is your, you see, this is RAB distance has been taken, and this side is RBC distance. So when RAB is quite large, then this point is. So you are going from one point in the valley to second valley. Okay. And these are these contour diagrams are this lines which you are seeing. This is line with same potential energy, and you can see this same potential energy, and you can get from here same potential energy. Similarly, same potential energy. You are going here, and then this is the point, saddle point, and this side is your. So one side is reactant, one side is product, and you are going from either this from this side or through a path. Okay, and this is your reaction pathway, and this is your saddle point. The same thing explained in 2D this thing. So what you do, you take a 3D thing and then you take a slice. Then it will look like this. Okay. And these things are known as contour map. So a bit about contour map. And that this thing I have taken from Khan Academy. So let's see if I can see that. What is contour map? Just 1 minute. Something. Yeah. Okay.
सर ऑडियो नहीं आ रही. सर ऑडियो नहीं आ रही है. ऑडियो है क्या वीडियो में?
अरे
नहीं, मुझे नहीं आ रही. पता नहीं किसी और को आ रही है.
No, sir, audio नहीं है. Sir, audio नहीं आ रही.
सर कैप्शन ऑन कर सकते हैं. कैप्शन ऑन करें.
Is it coming? अभी आ रहा है या नहीं आ रहा है?
नहीं आ रहा सर. आप कैप्शन ऑन कर दो तो आ जाएगा. मतलब एटलीस्ट देख लेंगे क्या बोल रहे हैं. तो फिर आप ही एक्सप्लेन कर दो.
So you can just open the subtitles. I think we'll manage with that.
Okay, so what I will do, I will again start. Okay.
Sir, even I have posted the link in chat.
Okay, so do you understand this a bit?
Yes, sir.
Is it clear now? What is contour? You see, so these lines which you are seeing, it is basically taken, different slices has been taken, and these lines are basically one potential energy, same potential energy. These are called contour lines. So this will have same potential energy. The all points at this will have same potential energy, and certainly potential energy will differ between this and this, right? One contour, the coordinates which falls on one contour line will have same potential energy. The second will have different than the first, but all coordinates which falls here will have same potential energy. So you can think of, you are going from crossing. So from this side, potential energy starts increasing, increasing, increasing. And then here it is maxima. And then again it falls off. Is this clear? So basically you are taking a slice of XY plane, okay, at a given Z value, where Z here is potential energy, and then you are squeezing to show it in 2 dimensions. Is it clear?
Yes, sir.
Sir,
Yes.
so what is the second curve from the top right corner in this contour plot? I mean, it's a bit square
one?
shape. From the
This one?
top right corner.
Oh,
Yes, sir.
here you are talking about this
Mhm.
side?
Yes, sir.
Yeah, so if you go into graph, this will also come. This is where dissociation happens. Okay, this side. Remember, this side dissociation happens. This molecule is no longer, like a molecule. So it is not like this kind of curve which you get in harmonic oscillator. So our bonds are n-harmonic oscillator. Okay. So when you are falling off and then atom become dissociate, then you go to this side. But if there is some bond, then you are in this region. Okay. So these are all slices. But again, this is a contour line, so potential energy will be same. This is contour line, potential energy will be same along this coordinate. Okay. Similarly, this side, potential energy will be same on this line. So these are all contour lines. Is it okay? So in this picture, you can think of this side, what I am showing is, one direction, which is the lowest energy pathway. And this is just perpendicular. So you can think of in this diagram, okay, this is lowest energy pathway, and you are cutting slices, am I right? And the other part will come from this side. This will have some potential energy, am I right? High potential energy. If you cut slices, then this will fall in this region, high energy one. So this is low energy, lower energy, higher than first one, higher than second one, and this is, we are going towards more higher value. Okay, so that is a kind of thing which you are looking at. So you can think this will not take this path, right? It will take this path only. We are going from highest energy to highest energy side, both way. So keep those things in mind. Is this okay? Is it clear?
So but without any values we can't tell ना कि जब हम मतलब वो वैली से सैडल की तरफ जा रहे हैं we won't even know कि actually वैल्यू इंक्रीज होगी नहीं because आपने बोला कि वो वैली और सैडल है तो I can see कि एनर्जी बढ़ रही है otherwise I'll need some points like some values of the graph also ना कि मुझे पता कैसे चलेगा कि वैल्यू इंक्रीज हो रही है.
कोई भी वैल्यू होगा, जस्ट फॉर एग्जांपल यू टेक सम पोटेंशियल एनर्जी वैल्यू,
दे
it
देंगे.
will show like this on
Okay.
2-dimensional. Okay,
Okay sir.
plot same energy value. Same energy value means you take one slice, नीचे से लो एक slice, right?
Yes sir.
स्लाइस लेना है जेड एक्सिस के तरफ, जेड की कोई एक वैल्यू ले लो, यहाँ पे जैसे 0 to -600. So what you are trying to do is, suppose I started taking -50, -100, -150, -200. I'm taking slices, and then we are just collapsing it. So -50, suppose you have this, then ये हो सकता है -50 का वैल्यू हो, ये -100 का हो, नहीं, just go opposite way, am I right? -200 will be, so -400 will be lowest energy, am I right? And so here it is like -400, -350, minus, you know, so it depends कि कितने बीच में तुम स्लाइस लेते हो. So this will be of lowest energy. ये देखो भी यहाँ पे है तो लोएस्ट एनर्जी है, जैसे ऊपर जाओगे हायर एनर्जी वाइब्रेशनल लेवल.
तो लोएस्ट एनर्जी इन टर्म्स ऑफ मैग्नीट्यूड बोल रहे हो ना?
यस,
लोएस्ट एनर्जी इन टर्म्स ऑफ मैग्नीट्यूड बोल रहे हो ना?
लोएस्ट एनर्जी व्हेन आई एम सेइंग नो, आई एम टॉकिंग अबाउट माइनस, फॉर एग्जांपल व्हेन आई टेक दिस ग्राफ, -400 इज लोएस्ट एनर्जी.
ओके ओके ओके.
ऐसे ऊपर जा रहे हैं तो हाई एनर्जी होता है. तो पहले यहाँ से हमने दिखाया कि यहाँ पे एक स्लाइस लिया था, इसके बाद यहाँ का एक स्लाइस लिया था, सर्टेनली दैट साइड. सो ये स्लाइस यहाँ लिया, फिर यहाँ लिया, तुम देखो इसी में देखो स्लाइस, राइट?
ओके.
ऐसे स्लाइस लोगे, यहाँ पे स्लाइस लिया, यहाँ स्लाइस लिया, इसी को दिखा रहे हो तुम, ठीक है? ऐसे देख रहे हो कर्व कैसे है, ऐसे है ना?
यस सर.
यू आर सीइंग हियर,
यस सर.
राइट? दैट्स व्हाट यू आर लुकिंग एट दिस पोजीशन. अगर तुम यहाँ पे नीचे हो तो ये ऐसा ही जाएगा. ओके, बहुत ऊपर जाओगे तो क्या होगा, ये बहुत वाइड होता जाएगा. सो दैट्स व्हाट इज शोन हियर. इसीलिए मैंने ऊपर दिखाया है कि ये दोनों जो है, बेसिकली आपने यहाँ का स्लाइस लिया, ये ऐसे दिखेगा. अगर ये स्लाइस लिया, सपोज ये सारे एक एनर्जी के हैं, ये सारा ऐसे दिखेगा, बिकॉज दिस इज 2-dimensional, दैट्स व्हाई इट लुक्स लाइक अ लाइन, बट इट विल बी लाइक दिस, विच यू कैन सी फ्रॉम हियर. अगर यहाँ पे मैंने एक लाइन डाला, स्लाइस कैसा शेप होगा, ऐसे जाएगा ना नीचे.
Yes sir.
So that's what is shown here. So this is one energy. So suppose this is -350. यहाँ पे -250 का एक लाइन होगा, -50 का एक लाइन होगा. ओके, सो यू आर गोइंग फ्रॉम लोअर एनर्जी साइड, तो यहाँ से लोअर एनर्जी धीरे धीरे हाई होता गया. So this is your reaction pathway, and now you are going towards product side. In between, this will be the highest point, and that is your transition state. Is this okay?
Yes, sir.
Any questions?
Sir,
Yeah.
क्विज माइनर से पहले होगा या क्विज 1 या बाद में?
Quiz 1 I think बाद में होगा, when my part will be done.
Okay.
And if you have any question regarding this kind of thing, you just ask Kuntal sir, because he is the coordinator for this. Huh? but that's what we think, I think, but just ask him one more time, because I will not be 100% sure, but you know, I remember that last time we did it like that, and I believe it to be same. Okay, कब है तुम लोग का minor?
19 से चालू
19.
इस 19 को CML का 19 से 23 तक चलेगा.
So मैं तुम लोग का सारा slides डाल दूंगा. And I think if you want to download the lecture video, then you can download it from MS Teams. Okay. Anyway, I will be putting all the slides on MS Teams, so you can download it. Today I will again put few more tutorials. Please go through it, and in 1 day or 2 days we will discuss all the tutorials wherever you have a problem. Is this okay?
Yes.
Yes, sir.
Oh, okay. So I will stop today.
Sir, I have a doubt.